All right, so our last and final lesson in percent is Unit 9, Compound Interest, 9.8. If you take a look at the homework sheet, we've got 9.8 as listed for page 24. It's just a one-page lesson. You are going to get a quick try at seeing what interest is like in real life. Compound interest basically means that you not only earn interest on the original amount that you had, the principal, but you also earn interest on your interest, which is a good thing if you are saving money, if it's your savings account, but it's a bad thing if it's a loan, because that means they earn more money on you. Okay, so here we go. If we look at page 24 in our packet, it starts off with the formula. And that formula is very important for you to use to be able to solve these problems. So let's talk through. It's a little bit different from the simple interest formula that only had multiplication. It's a little more complex. Notice it's got some exponents and it has a fraction in it. So you're going to need a calculator for sure for this, and it would be helpful to have a calculator that has fractions. So A is the amount accumulated. That means it's the total amount with the principal and the interest. And as you noticed with simple interest, there were some problems where you had to calculate the total right here, find the total amount. And some of you just found the interest and forgot to find the total by adding. In this lesson, it adds it for you. And that's why it's doing 1 plus the rate divided by the number of times compounded, because it's taking 100% of your amount, your principal, and adding on the interest each time. All right, the principal is still P. The rate as a decimal is still R, but now we have a new letter N. N is the number of times compounded per year. So, for example, if it says semi-annually, think about how many times per year that means. First of all, the word annual means per year, and semi-annually means that n equals 2 because it's 2 times per year. On number 2, when it says compounded quarterly, that means 4 times per year. So go ahead and write n equals 4. And you can go through and take a look at each of the different problems. It just depends on the type of account for how many times it's compounded. If it says compounded monthly, you're going to write n equals 12 because that means there are 12 times you get interest in the year. Again, it's always per 1 year. All right, looking at this, time is again in years. If you don't know the number of years, you have to convert into years. But I believe all these problems we gave you the number of years. Okay, so here's the formula. A equals principal times, in parentheses, 1 plus the rate as a decimal divided by the number of times it's compounded. And that is all to the power of, so this is an exponent. Make sure you use the exponent key, the caret key. It's to the power of n times t. And for some people, it might be easier just to do n times t first and then plug it into your calculator, because the problem is that if you don't use parentheses here, it won't multiply. It'll only put the n in the exponent and the t will just be after, and it won't work right. So please be careful with this formula. Okay, so basically you're just going to take each problem and plug the numbers into the formula and figure out what number you're missing. What is an account balance if you start with $7,300 invested at 7%, compounded semi-annually for 3 years? What I would do is just go through all the letters and put in the numbers. So we already did n equals 2, and that's because it's semi-annually. That means 2 times per year. We can write down the P for principal would be right here. P equals 7,300. And we've got R, the interest rate, but please don't write 7%. Remember, a percent is out of 100. So you have to divide by 100 to write it as a decimal. That would be 0.07. Not 0.7, because that would make it 70%. That would be a lot of interest, which would be awesome if you were saving money, but not probable. Okay, lastly, the 3 years would be t equals 3. Now you just put in all of those numbers into the formula they gave you at the top. And I'm just going to erase this because it's kind of hard to read. I kind of made a mess of it. Okay, so here goes. A equals 7,300 because P was 7,300. And then I put a parenthesis and I write 1 plus. Instead of R, I'm going to write my 0.07, so 0.07 divided by 2 is N. So again, we're just plugging into the formula, this formula right here. Okay? And then you have to put NT in the exponent. So 2 times 3 is in the exponent. You might just want to write it as 6. Now, this is going to require you to carefully type this into your calculator. Please make sure that when you do 7,300 times, you use parentheses, 1 plus. And if your calculator doesn't have fractions, you want to do this also in parentheses. Can you see how this is kind of compounded and it's somewhat difficult? That's why, because of all the parentheses and exponents. But you can totally do this. Once you get the hang of it, you should be able to calculate these without much trouble. Your final answer, if you put it in right, which please do actually try to put this in your calculator, and if you don't know how to do it, please ask questions. It should be $8,973.56. If you don't get that number, please go back and check and see what went wrong. Okay, if you did get that, great job. Keep going. So let's try one other one like this. Actually, let's just do the one that's in months. How about this one? 4. Just because it's got the 12 months, just to make sure you understand that one. What is an account balance? A equals 10,000. Make sure you put the right number of zeros times 1 plus. And now how do I write this percent? I have to divide by 100. So it should be 0.05 over N. And N was 12 because it's monthly. And that is to the NT power. But N is 12 and T is 20. So you can either do 12 times 20, or you could do that ahead of time. Please make sure that whole thing is in the exponent. And you should get, make sure you do this yourself, pause the video, $27,126.40. If we look down at the bottom, this is asking us to compare the amount of money if the money were invested in simple interest versus compounded. If you remember in the video yesterday, I told you simple interest is not used, but we were learning interest, and so that's why we were learning it that way. Compound is usually the way that the interest is calculated. Okay? So, and we're going to say compounded annually, which means N equals 1. That's just 1 time per year. So even with just 1 time per year getting interest, you still will notice a difference. So I would even split your paper. I would do simple interest here, and I would do compound interest over here. Do 2 calculations for each one, and please give both answers. Oh, actually, wait, I'm sorry. It says to tell how much more. So compare. So you basically just take simple interest and subtract it from compound interest. So I would do, to find your answer here, I would do compound minus simple. And it should always be a positive number. You should always get more money with compound interest. Okay, so remember, simple interest is I equals PRT. So if you need to look back at that video, go ahead. But basically, you're taking this $5,000, you're multiplying it by 10% as a decimal, which is 0.10, and multiplying it by 5 years. Compare that amount. That's just the interest, though. So you have to add on the $5,000. So do 5,000 plus the answer that you just got, and compare that to using our new formula. A equals P times 1 plus R over N to the NT. So 5,000 times 1 plus 0.10 divided by 1 this time, because we said n is just going to be 1, to the 1 times 5, or just to the 5th power. Compare these two rates, and you should find that we've got, let's see, for just the $5,000 times 0.1 times 5, that's $2,500. But remember, you have to add that on to the 5,000. So it should be $7,500. When you multiply this whole thing out, you'll notice it's over 8,000. 8,052.55. And so to compare, you need to subtract, and you could write that maybe over here. 8,052.55 minus 7,500, which is quite a bit more. And that's just changing it to compound interest, where you earn money on the interest you already made. So you should find that you have $552 extra dollars and 55 cents more with compound interest. Does it make sense that when you're saving money, you'd want to get that, but maybe when you're borrowing money, you wouldn't? Okay, please let me know if you have any questions, and have a great day.